Okay, section 2. This one is a pretty big section in terms of calculations and vocabulary and interpreting. First section, what we started with is we're looking at linear data and we want to measure the strength of the relationship, and so we calculate correlation. We talked about the idea with regression, so I want you to write this down, is we are looking for a linear trend so that we can predict y based on x. So this is the whole idea with regression. We're looking for a relationship so that if we have an x value, we can use it to predict a y value. That's what we're going to do today. We're actually going to find that linear relationship. So, finding the line of best fit. Here's what's hard. There's 3 different ways you need to know how to do this based off of the information that I give you. The first way is using the summary statistics. For x and y. That is the hardest one, or the one that requires the most work at least. The second way is you have to be able to read computer output. And the third way is using your calculator. And that's when you have raw data. You need to know how to do all 3 separately. The vast majority of the time, you're only going to be able to use one method and not the other 2. So this is not a case of choose which method you like best. Most of the time, you're going to have to use one. Okay, so we are going to look at this data right here. So it's only 5 points. We have the 5 x values, the 5 y values. We see this scatter plot of that data over to the right. So we see that's probably a strong relationship. Maybe it's definitely positive. Looks to be fairly linear. And so we want to find the equation of that relationship. The first way that we are going to do that is we are going to use the summary statistics for x and y. So that's what we're going to do first. It involves these formulas right here. These are the formulas that are on your formula sheet. These are the formulas that are on your formula sheet. This is the general regression equation. So if we write that y hat equals a plus bx, x is the input, y hat is the predicted y. That's what the hat means. A is our y-intercept, and b is our slope. So like any other linear equation, we are going to have to find a and b. You'll see right away from those 4 formulas, you have an equation to find b. It involves r and the standard deviation of y and the standard deviation of x. You are not going to have to find r. So what we're going to do is we're going to use that output at the top, up here, and up to here to find those values. So our b is going to be r, bless you, times sy over sx. Does anybody see the r value in the output above? Kelsey? 0.9. Okay, Pearson correlation, thank you. That's the r value. So that's this number right here. So that's going to be 0.949. And then if we look at this x and y part, here is the standard deviation. So the standard deviation of y is 5. Standard deviation of x is 1.581. So if you can calculate that, please. And I think you get about 3.00. You all agree? About 3.00? Okay. So then this top equation is the equation to find A. What I want you to notice, it has A in it. It also uses B, though. So in order to find A, you're going to have to find B first. So we have y bar is equal to A add B times x bar. What are y bar and x bar? Averages. They're the means. So that would be this right here. So the mean of y is 7. Our b is about 3. X bar is 3, the mean of 3. So we get our a value then to be -2. So then finally, our answer would be y hat is equal to a plus bx. And if we had a context, we would say x represents something, and we would say y hat represents a predicted something, whatever the context is. That is the first way to find the regression equation. Questions for me? Okay, I want to show you on the calculator real quick. Do you all remember how to find R on the calculator? Okay, that's what I want you to do is find R, but please use these numbers right here. So I want you to put the X's in list 1 and the Y's in list 2. And we already know when you find R, you should get about 0.949. Okay, from that output, you should also see A and B. You should get an A value of about -2 and a B value of about 3. We agree? Okay, if I give you the raw data and no computer output, all you're going to do is plug it in the calculator and give me your answer. That's it. You don't have to show any work. Besides, of course, defining X and Y hat. So that would be if I just give you a data set that has all the X values, all the Y values. So that's the second way you have to be able to find the regression equation. How do we feel? Priyanka?
All you have to show is just the equation and then
Just,
the predicted.
yep. Okay. I'm going to talk about 2 or 3 more things, and then we can take a break, do some multiple choice, maybe play a quick round or 2 of Family Feud. Sound good? Okay, so there's some pieces of vocabulary I need you to know. I'm going to make up a context for this just for our vocabulary. Let's say that X, in this case, represents the number of hours that you studied for a test. And Y hat is your predicted score on that test. So for example, the 0.1, 2, a student that studied for 1 hour scored 2 points on the test. So remember, this is X and Y. Y hat represents when we used the equation. So Y is the actual score, whereas Y hat is just a prediction. Okay, so little throwback to algebra. One thing that you have to be able to do is you need to be able to interpret the y-intercept. It's going to be very similar to what you did in algebra. Y-intercept, when x is 0, our y value is -2. So when x is 0, our y is -2. We need to put that in context and in words, though. And remember that -2 is a prediction. So we would say for a student that studies 0 hours, the predicted test score is -2. Now, does that make sense in terms of the context of the problem? No, right? You can't get a score of -2 in all likelihood. Most of the time, the y-intercept is not going to make sense contextually. Anybody remember from your reading what this is an example of? Extrapolation. You had the right word. Yes, extrapolation is very dangerous. So that is the next piece of vocabulary I want to tell you. Extrapolation is using your regression equation or your line to predict a y value for an x outside the domain used to create the equation. So for example, our points had x values between 1 and 5. So our equation is only appropriate for x values between 1 and 5. The issue with extrapolation is that we don't know the trend outside 1 to 5 for our example. So we don't know, is our line still the best fit for the data outside 1 to 5? Maybe yes, maybe no. The way that you often see extrapolation is you might be asked a question like, would you predict the test score for a student that studied 10 hours? And you would say, no, this is extrapolation. I don't know that this would be the best fit for students that study more than 5 hours. Last thing, and then we'll take a break. You also have to be able to interpret slope. And our slope is 3. Remember that slope is the change in y over change in x. So when y changes by 3, x is predicted to change by 1. Remember, this is a prediction. That's the biggest thing that I'm going to be looking for. So I'm going to say for every additional hour a student studies, the test score is predicted to increase by 3 points. Any of the words I underlined are the most important ones. So it's important to say prediction or on average. It's important to say increase or decrease to tell me if it's a positive or a negative. I've got one question before we take our break. A lot of students will leave out this additional. And so they'll write, for every hour a student studies, the test score is predicted to increase by 3 points. Or, no, they'll say for every hour a student studies, the test score is 3 more points. So I can't come up with it. But this additional is important. Because without the additional, we're ignoring the y-intercept. So I want to see that term. Any questions on what we've talked about so far? Extrapolation, slope, y-intercept, reading the summary statistics, anything like that? No. Okay. So
What
at the
is the difference between the summary statistics and computer output?
computer output we're going to look at in a minute. Okay. So the one we haven't talked about yet is computer output, which is on the next page. So if you can go to the next page, let's talk about that real quick. Okay. So what is really nice about the computer output is that it just straight up gives you the regression equation. Oftentimes, though, you're not going to have that part I circled. You're only going to have this part, and you're going to need to be able to read it. So in the previous computer output, you had x and you had y. What's more important, or what's different in this one, is we still have x, but we have constant. Okay, so here's what that tells us. Coefficient is the coefficient on either the constant or x. So that means that 3 is attached to x, and the -2 is just a constant. It's just attached to a number. So our y hat then is 3x plus -2, or normally we write it as -2 plus 3x. So what is important is seeing that word constant.
Does it matter if you write 3x plus
Nope.
3x minus 2?
Nope.
Why do they write it a different way from both?
I don't know. I would love to know, but I don't know.
They just think they're better.
Maybe. Okay, one more fun fact. Do you see that this is r squared?
Yes.
Right? So our r squared is 90% or 0.9. Could we find r from here? Yeah? So you're going to take a square root. Now, do you remember with the square root you get plus or minus? So how do we know that it's positive 0.949 besides the fact that we already found it before? How do we know it's positive and non-negative?
Slope is positive.
Okay, slope is positive, which tells us r will be positive. And then the computer output, you can see, gives us the scatter plot, and it gives us a scatter plot when the line is fit to it.
What is that last one?
Such a good question. You'll read about this, and it's the next thing that we learn about. It's called a residual plot. It helps us determine if our model is a good fit. So if our line is a good fit for the data. Before you do an example, the last thing I need to tell you, and this is really, really important, is you only input for x, never y. So your equation, you are only allowed to input for x and predict y. You are never allowed to input for y to predict x. Okay. Here is the example that I would like you to do. The following data shows the miles driven on various used cars and sale prices in dollars. Find the least squares regression line, predicting miles driven based on sale price. So start by taking a minute to put all this information in your calculator, please.
Oh no.
Oh, yeah.
So many numbers.
What did you get? What did you get for B?
For A, I got 39563.2.
What did you get for your slope?
Slope is -3.6.
Okay, that's what I got also.
For B, I got -3.6.
Yeah,
Okay, first slope, I believe you should get -3.61. If you didn't get that, you did something wrong. Okay, so figure out if you did something wrong, what went wrong, and then make sure you interpret slope and y-intercept.
You weren't here. You gotta change like your theme. I don't know.
Yeah, that's those mistakes.
It's an easy fix. Don't worry about it.
So you would be
There we go.
That's just pretty simple.
Mine's at least not.
Wait, I just right now brought that, but I'm flipping them again.
Mine's, carries that.
I think I typed it in wrong.
It's true.
Yeah, I got it.
Alright, well, how you gotta get it?
What do you mean, right?
I don't know why.
I don't know. I think I typed in my numbers wrong.
Coulter, do you need help with your calculator?
I just don't know that now.
No, I got that.
Oh,
right.
that's what you needed to do.
But it still says.
Yeah, I got here,
Still says.
stat, stat, arc 8.
What?
Okay, go down to go to.
Sir, I'm gonna have to.
What's your deal, Shmuel?
What a yacht.
Do you have this
Yeah.
data in list one and list two?
Secretly after.
I'll send it.
It's not secret.
My ballot.
Okay, here's why. You have an extra observation.
Oh, but it won't let me clear it.
You should be able to delete that observation.
What?
How?
Hitting the delete button.
Why would I do that?
$10.
Clear?
Okay, hey, I
down.
won't say a word for 10 minutes.
No, because you don't talk.
No, what if like she calls on me?
Oh, there we go.
Still can't talk.
Hey, do you all have an equation with interpreting y-intercept and slope?
Oh, I got my.
Oh yeah, we don't have anything written down for my interpretations that I asked for. So, please do.
I wasn't talking. I was just trying to fix my problem.
What'd you get?
I actually got it.
Negative, wait.
Oh wait, no, it's the one that had.
Yeah.
Mine's wrong.
You have to make sure that you're putting the right
'cause it's
list.
predicted.
Because this like
You're right.
price is list one, miles
That's that.
Wait, so I just put in
That's what we
everything
did.
that's supposed to be.
Well, you can flip it.
Oh, yeah,
You
right.
can just then, when
I
you're
would
figuring it
actually
out,
$10
flip
yeah.
this one
Nope.
and this two.
Okay.
You're really well.
And you go to,
This one should be.
What?
Why do I have to say additional again?
So here.
Because it accounts for the y-intercept. Or somehow across the point that is one is changing, the other one's changing too. I just have had students word it before in a way to make it seem like the y-intercept was zero. Like it was just
800?
3
Wait,
times
wait.
that.
I got 161872.
So that's why I
I
wanted
got
it to be
862.
I got 919.
How does that work?
I don't have a problem with it.
I think you guys just put it in wrong.
yeah, I mean, like.
Yeah, I just put.
Hey, Kelsey, what did you get?
For
Oh,
It's plus.
Plus 163,000?
You silly goose.
Did you interpret?
Well, seems right.
What'd you do?
161,919.
I got 161872, but
I got 161,868.
I got 161,862.
You all these people back here? Coulter's
I think
wrong.
that's-
I think we
Hey,
all put
they-
it into our calculator.
What did you get?
No, I don't trust me, I'm
How
not
much
sure.
you think it showed?
Right, I just want to know what you got though.
163183.
That's not what I got.
Miss Nita,
What'd you give us, Nita?
I got 161,866.
let's go.
I got 862.
I got 872.
I got 868.
Okay, it doesn't really matter as long as you're close. That's what I.
Wait, why is it like? Why is it changed? Like, why do we all agree? Different A's.
My guess would be just error based on the rounding in the calculator.
Let's go.
Okay,
go switch your calendar.
I'm sick of waiting, so we're just gonna start talking. This is what I would want to see for your work. That's it. Equation, x equals y hat equals predicted number of miles driven. I want to interpret slope and y-intercept. So I either need 2 volunteers or I will just pick 2 of you. Anyone want to interpret either? Kelsey, thank you.
For a car that costs $0, the predicted miles driven is 163,183 miles.
Beautiful, thank you.
Clap.
For a car that costs $0, we predict the sale price to be whatever you got in the 160,000s. Slope?
For a car that costs $1.
So like every dollar added for every additional dollar. What would it be for every additional dollar?
Car cost X.
The car costs like the miles driven.
Is 3.61
You
miles.
say
Is negative
for
three.
a car that costs
Is wait.
$1,
It's
Is
predicted.
the cost would be
is
161.
Tanya?
162.
Tanya's gonna put together all your great
it's
ideas.
predicted to increase or
Room to guys.
For every additional dollar, the number of miles decreased 3.61 miles.
Okay, so every additional dollar, the number of miles driven decreases by, I got 3.6. I don't know if that's what you got also.
Yeah.
Wait, what?
Predicted to.
Predicted to. I'm gonna take off a point if you do not say predicted, on average, tends to, something like that.
would you take off a point if we just said for every additional dollar? Would we have to say for every additional dollar of the price
Oh, that's,
of the car?
You can just say as much as you
it
can.
depends.
I'll just throw out words.
If this was part of like a multi-part question,
Yeah.
as long as you said sale price somewhere, I would give you credit. But if that's the only thing I asked you, I would want more context.
Okay.
I don't think this is realistic. Because I would buy a $1 car for that many miles really quick.
I think a free car with 161,000.
Yeah, if the car was free with 161,000,
Okay.
I'd definitely buy it.
I want to talk about that though. Is this model appropriate to predict the number of miles driven if we look at a sale price of
Would it be
$1?
Can't be
extrapolation?
determined because
It would be extrapolation, and what is the danger with extrapolation? Why do we not want to extrapolate?
It's outside the domain.
You could
Why does
say
it matter?
that the issue is we don't know trend outside.
Because using regression.
No, but she's saying
That's
why
what he
does
does
it
that
matter?
from.
You could say using the regression line to predict y hat for x outside domain used to create equation.
It's because we don't know if the line of best fit is still the best fit.
You're gonna
Exactly.
Oh, I got it.
Oh, I'm gonna get it.